this video about keepalived, and I'm here with Smiley the Yorkie, who is a doctor of IT philosophy. Do you see what I did there with doctor? How clever, hey? Anyway, Smiley, say hello to all the subscribers and the lovely people watching this video.
Hello, everybody.
So, with that in mind, and you obviously enjoying the fun part of this video, let's get on with the lesson. So I hope you enjoyed Smiley, our doctor of IT philosophy, helping out there at the beginning of this video. So if you like the video, please give it a thumbs up. If you want to comment, please do. If you want to share, then share it. And last but not least, please subscribe for more great content. So today, as it shows here, we're going to be having a look at Ubuntu Linux redundancy with keepalived. So it's understanding and configuring keepalived. So that's what we're going to learn today. We're going to learn how to use keepalived for Linux redundancy, as I've already said in the previous slide, so I'm just repeating it here. So firstly, what is keepalived? Well, keepalived is a system daemon that was originally designed for load balancing and failover solutions. Now, it was often used, as we see here, with HA proxy or Nginx. Now, I'm actually going to do some videos showing this in action because it is perfect for grouping servers behind the load balancers that we can use with regards to keepalived as well. As with most redundant-based systems, the premise of keepalived is to maintain a virtual IP that switches between servers when one fails. Now, a virtual IP is an IP that doesn't really exist, but we configure that, and you'll see that in action in a minute anyway. The above makes failover seamless for users accessing the service. So how keepalived works. Okay, so here we've got a topology overview of a web server 01 and web server 02, and we can say that the internet access is a PC on the right here. Now, keepalived uses VRRP, where one server is the master and the others are backups. So here, as we can see, we've got web server 01 is the master, and the backup is web server 02. The master server manages this VIP address that I've got assigned here as 192.168.1.3 until a failure occurs. Now, when the master goes down, the backup server becomes the new master and takes over the VIP. From the perspective of the internet access host, it will utilize the VIP address of 192.168.1.3 as its gateway, not the physical addresses of the systems. Because look, if it uses 192.168.1.1, the master web server 01, and that goes down, well, then it is not part of this VRRP installation or configuration. So therefore, it won't automatically switch to the backup. Yeah, the backup will still become the master and it will still use this VIP address, but because we're not connecting to the VIP, we're connecting to this physical. Well, that physical isn't available anymore. That's why we connect to the VIP. The VIP is always available. So the VIP currently sends data via the master server, web server 01. But if that goes down for any reason, then the VIP address is still available, as I've just said, and it sees web server 02 as the new master and sends data there. So let's have a look at a configuration example. It's going to be a basic configuration example as well, and we'll break it down line by line. So we need to configure the following file once we've installed the application. So it's /etc/keepalived/keepalived.conf. And this is what we need to add to it. So we need to add one to the master, and we need to add one to the backup. Now, when we go through it line by line, what each line does will then become obvious. Okay, so we start with the VRRP instance, the first line. That details the virtual interface configuration for the VRRP service daemon, and that creates the virtual IP instances. So any of the other systems that need to be part of this one need to have this VRRP instance within it. The state master designates the active server. So on the backup, we put in there state backup in capitals, and we'll see that in the live demonstration soon anyway. So that will be used to designate the backup server. The interface parameter assigns the physical interface name to this particular virtual IP instance. So we're basically saying Ethernet 1 here, interface Ethernet 1 is what we'll connect to, whether that be direct or whether that be via a switch or a router. It will be the one that connects to the backup. So the virtual router ID is a numeric identifier for the virtual router instance. Now this again must be the same on all router systems participating in this virtual router. The priority specifies the order in which the assigned interface takes over in a failover. Now, we've only got two systems, so we've got a master and a backup. Now, as long as the backup's priority is less than 100, as we stipulate here, the master must have a priority value set to a higher number than the priority value of the server configured as the state backup. Now, if we had two backups and there was a particular one that you wanted to take over as the master, you would set that at a higher priority than the next backup that you don't want to take over as the master. The authentication block specifies the authentication type. So we have an auth type, which is password, and the auth password is, in this case, let me in one with a capital L. And the virtual IP address parameter specifies the interface virtual IP address. So this is the address that any host will use as their gateway because it's the VIP address. So let's go ahead now and configure this on the live systems and see it in action. So here we are at the live systems to show you what I've already completed. So we have the master system for keepalived. We have the backup system for keepalived. We have a start node for pinging the keepalived virtual IP to show it working. We also have a QFX, a virtual QFX configured, and I've just made up a VLAN here, look. So we have all of the interfaces required, interface mode access, and the VLAN members keepalived with an actual VLAN configured called keepalived in VLAN 100. So if we go to the master node first, you can see that we are already in etc. keepalived. I've already done the configuration work of the basics, which I'd already shown you. So now what we need to do is you will note when you come into here and you do an ls that there is no files in there. There are no files. So you have to start the keepalived.conf from scratch. So if we vi, I tend to use vi, you use whatever editor you want to use. I could cat it, but I'm going to vi it instead to show you. So we'll do a vi keepalived.conf. So in here, as per the PowerPoint demonstration, we see the configuration for the master. So we have the instance test1. We have the state is the master. The interface is ENS4. The virtual router ID is 100. The priority is 100. The advertisement interval is 1. It's not really that important, but we'll keep it low. We'll keep it at 1. And the authentication is type is password, and the actual password is let me in 1. And the virtual IP address. Now, if we go to the backup and we look, again, inside etc. keepalived, vi keepalived.conf. So we see the exact same name of the instance, test1. The state, though, is backup. The interface, again, is ENS4. The virtual router ID, remember we said it was important that it remain the same as well, so that's 100. But we've lowered the priority here to 90, so that it is the backup. The advertising interval is 1, and the rest of it's all the same, including the virtual IP. What we have on the master, if we do an escape :q ahead of that, and if we do a cat /etc/netplan/ the installer YAML, you'll notice that ENS4, which is the interface that we've included in our keepalived.conf, has the address .1, as we showed in the PowerPoint presentation. Okay, and it has its roots via the virtual IP, which would be the same as the backup if we do an escape :q and we do a cat /etc /netplan, and we know it's installer config.yaml. So we have the same here, but we have the IP address .2, but the roots for this network are via the virtual IP. So what we'll do is on the master, we're going to check the status. So we'll do system ctl status keep alive D. Okay, so we know it's active and running. So we'll cancel that. Let's make sure we have it on the backup as well. System ctl status keep alive D. Okay, so currently at the moment it is not running on the backup. So what we'll do is we will now start it on the backup. System ctl start keep alive D. And now we'll have a look at the status and we'll note that it is also now up and running. So if we Control C out of that, so let's make sure we still have it running on the master, and we do. Let's make sure we have it running on the backup, and we do. So all is good. Let's just go back to the master and come out of that, and the backup and come out of that. And so on the start node, we also have, if we cat /etc /netplan / our YAML file, you'll note that we have just a made up address in the 100.0 / 24 network range. Okay, and again, it's going to go via 100.3. So the test is, if we ping 100.3, do we get an auto failover as we expect to have? So let's try it. Let's do a ping 192.168.100.3. And we'll just keep that going. Okay, so we can actually ping .3. So we're going to shut the master. So we will now system ctl stop keep alive D. Now let's check the status. So it's stopped. Okay, it's no longer running. Now the question is, from the start node, are we still being able to ping? Yes, we are. So you see, we didn't even get a dropped packet. We didn't get a single drop packet on this virtual IP address. So let's Control C that and we'll start the ping again. So we had no drop packets at all. So it wasn't even noticed that the backup took over from the master with regards to that virtual IP address. And this is how we can configure keep alive D for redundancy in Linux. And as I've stated before, we'll show in a separate video how we can use that with HA proxy and Nginx. Now let's go back to the PowerPoint presentation and we'll do a very quick summary and an end to this video. So let's quickly summarize keep alive D. So it's utilized for Linux redundancy, and it can be used in conjunction with HA proxy and Nginx. And as I've stated before, and we stated during the live demonstration, we're going to do a video utilizing those two applications along with the keep alive D. It uses VRRP and a virtual IP address. This is an address that doesn't actually exist. However, it is the address that will be used by hosts as the VLAN gateway within that particular VLAN. If you like this video with Smiley the Yorkie at the beginning and you want to see more of him putting his paws to good use, then let us know. We can potentially even rename our videos along the lines of Learn IT with Smiley the Yorkie. If nothing else, It brings a smile to our faces, and if Smiley can do the same for you, our subscribers and our new people that are watching this video, if he can do the same for you as you learn and enjoy our videos, then that has got to be considered an extra bonus. So please, if you're not already subscribed, then subscribe, because Smiley is going to be in way more videos and you'll see some nice smiles from him and maybe some good tricks. And as we've stated here, he will be putting his paws to good use on the whiteboard in the future. So make sure you subscribe for those videos. Until next time, take care. And if you've got any questions, let us know. Take care. Bye-bye.